Now let's look at function composition from a table and from a graph. Here we have a table showing values for x, f of x, and g of x. Use the table values to find f dot g of 1. So remember, when we have the dot notation, the first function that's applied is function g. So the first thing we have to do is take g and find the value of g when you input 1. And then from that answer, we're going to put that into f. I always like to draw a picture. You don't have to draw a picture. I just personally find it very helpful. So the first function we're going to apply is g, and then we're going to apply f, and then we're going to see what our final answer is. And the number we're putting in is 1. Now if you put 1 into function g, our output is a 3. Now what we're going to do is we're going to take 3 and we're going to put it into f, and we'll see our output is also 3. So f dot g of 1 is 3. Let's do that again. The first thing we did was we applied function g. So we asked ourselves, when x is 1, what is g of 1? So the table tells us that g of 1 is 3. We took that output and then we put that into function f. So when the input is 3, what's the output for f? It happens to also be 3. Let's try it using the parentheses notation. All right. So in the parentheses notation, the first thing we see is function f. So the first function we'll be applying is function f, and then we'll be applying function g, and the number that we're putting in is 3. So remember, these are our inputs right here. So if we have x is equal to 3, if we put it into function f, our output is a 3. Now we're going to take that and put it into function g. So when we put 3 into function g, we can see our output is a 2. And so g dot f of 3 is equal to 2. Again, let's do that one more time. The first thing we did was find f of 3. So we put 3 into function f, and we got 3 for an answer. We take that value, and we put that into function g, and we also get an output of 2. So that's evaluating function composition from a table. And finally, let's evaluate function composition from a graph. So in this case, again, we have the parentheses. The first thing we're going to do is we're going to find g of 1, and we have to do that from a graph. So using the graph of g, if we let x equal 1, we can see right here that the y value is 2. So g of 1 is equal to 2. And now we're going to go over to function f and say when x is equal to 2, let's find the function value. So when x is equal to 2, our function value is 5. So f of g of 1 is 5. We'll do that one more time. The first thing we did was find g of 1. So we went to function g, we looked along the x-axis where x is 1, and we found the y value was 2. Next, we put that into function f. So using the graph of function f, we went to x is equal to 2, we found the y value was 5. And so our final answer was 5. Let's try that again for another similar problem. So in this next problem, notice that we're using the dot notation, and in the dot notation, the function closest to our input value is f. So we're going to start by finding f of 2. So f of 2, on function f, we're going to go to the x variable, where x is equal to 2, and we find out that f of 2 is 5. And now we're going to find out what g of 5 is. To find g of 5, we go to the g graph. We look for where x is equal to 5. And here's our value for g. Now I made that a little big with my pen. If I look at that, it's hard to tell. So I'm just going to estimate that. It looks like it's close to 3. It might be slightly less than 3, but we're just going to approximate that as 3. And so our final answer would be 3. So from a graph, we simply find the first value, put that answer into our second function, and then find the final answer by composing the two functions together. And now it's time for you to try a few just like that.